Hey there. Welcome back to Coding at Home with the Code Hub. Sorry, just checking on my stream. It's flashing red. Maybe our bandwidth is a little bit low today. Welcome back to the live sessions. We're going to go through a little bit of what we did yesterday because apparently I went a tad bit too fast. Hey again. So yesterday we covered a ton. We covered variables and then we went right into conditional coding, which is a huge amount of material to cover for one day. And I know from talking to a few people that it might have been a bit intense, all that learning for the day. And I moved a little bit fast. So before we do anything else, I just wanted to say sorry. And I mean that because this is to introduce you to coding. This isn't to overwhelm you with all the stuff that there is to learn. There's a lot of stuff to learn, but we're going to try to take it slow today and go back over our conditions and our conditional coding and figure out how we might use those in our daily life and in our coding. So let's get started. Let's go. We're going to do a little review first. Okay, so to go back over what we've learned so far is we started out with the commands chapter in Everyone Can Code Puzzles, which was really secretly all about functions. Now the next chapter we got introduced to functions and how we write them. This is the syntax here. We have our func keyword with our function name that we provide, and it's got to be something memorable. Right at the very end with no spaces or anything, right at the end of that function name, we have the open and close parentheses that tells the Swift compiler that this is a function. That's followed by an open curly brace. And then inside the two curly braces, that's where we write all of our code for the function. Right, that one we've gone over a few times. That one we're starting to slowly get. And you know what? If you see these things and go, oh man, I forgot about that syntax. That happens all the time. This is why we have Google. This is why we have the internet and search engines, because programmers are always looking stuff up online. The next thing we went over after we covered functions, because functions are a great way to group our code and to make our code a little bit more reusable. Remember, I've talked a few times about programmers being kind of inherently lazy. It's definitely true. What we want to do is figure out what kind of repetitive tasks we wind up coding for, and write functions that will do those tasks for us and do a bunch of different operations. Like, for example, the example that we had was tying our shoe. There's a lot involved in tying your shoe, but luckily I can just say to the kids, tie your shoes, and they'll know exactly what I'm talking about. They might not listen, but they know what I'm talking about. Then we went over for loops, which is another way of reusing code and being a bit more thoughtful and of the energy that we spend writing our code. So the syntax for that was we have the for keyword, and then we have a placeholder in a lot of our for loops. And in fact, on all of our for loops, we use the I variable as our placeholder. Then we have the keyword in, and then we have a range of numbers. Typically, that starting number is a 1, the way we've been using it so far, followed by ... dots, which just says I want a range of numbers from the starting number to the end number. Now, you might be wondering, well, how does that work? Actually, what if the end number is lower than the starting number? That would be a really fun thing for you to try out over the weekend. So then we have the end number, then we have the braces again, and the braces again are a way of collecting the code that we want to be run over and over again in this particular loop. So those were functions and for loops. Those we've gone over a few times. And then this is some of the new stuff that we've covered lately. So we've got our variables and we've got our if statements. So for variables, we tried to stick with the var syntax, but it starts out with a var keyword, and then we name our variable something memorable again, like number of toes or name, and then the equal sign assigns a value to that variable. And we use the Learning Variables app from the Code Hub to sort of feel how our variables getting assigned a value then translate into us using it in a story later. So that was variables. And then yesterday we went right from variables and landed smack dab in the middle of conditional coding. So this is the simplest version of conditional coding. This is just the handling the case where if a certain condition is true, we're going to run some code. But if that condition isn't true, we're not going to do anything. We're going to ignore everything between those two curly braces in this case. So hopefully that little recap will reset ourselves for what comes next. Now, we use conditions all the time in our daily life. If you read Choose Your Own Adventure books, in fact, you can even see on the back of this one that we have a whole set of branches that you can follow to get to different endings. That's a lot like conditional coding. So when you get to the end of a section, it says, if you do this one thing, go to page 50. If you do pick another path, you go to page 74. That's kind of what we're doing with conditional coding. So now let's jump over back to the playgrounds. So that was our quick syntax review. Actually, do you know what? Before we do that, I want to show you one quick game. This is a game that we can play over the weekend here. So here's our syntax. So just like Choose Your Own Adventure, we can build our own game. So if you have a pack of cards at home, this is something you can do over the weekend or this evening. You can actually kind of show off your new knowledge of conditional coding. So this is called Conditional Cards. So the rules for this game are you have a pack of cards, ace, 2, 3, 4, 5 through 10, jack, queen, king, and an ace. If the card is red, when you deal them out to the two or more players, that team is going to get 1 point if their card is red when they flip it over. Otherwise, you're going to award the other team 1 point. So in this case, we're only playing with 2 teams. And this game is going to go very fast. Because if I have a black card and the other team has a red card, they're not just going to get 1 point. They're going to wind up getting 2 points. Now, if we both have red cards, then we both get a point. And then if we both have black cards, both teams get a point. So typically the way you'd play this is you'd set up with 2 different groups. You'd deal out 2 piles of cards and you'd go through the cards, flipping them over one by one, recording how many points each team gets. And then when you're done with the pile of cards, because they should each have, because it's 2 teams, they should have an equal amount of cards. The winner is the team with the most amount of points. So you can see here we're using a condition, this if card is red, and then we're using an else statement. And we'll go play around with this a little bit in playgrounds to really get a feel for why you'd use this and when you'd use this. Now, if you want to get super advanced, there's another version of conditional cards that maybe we'll look at a little bit later in the session. But for now, let's go back to our playgrounds. So if I go to the book quickly, you don't have to go to the book, I'll show you. This is what we were doing. These were the playgrounds that we were going through yesterday. We went through the introduction, checking for switches, using else if, looping conditional code, and we even did conditional climb, which is a bit insane to try to get through all of that in one session. Again, I'm very sorry. So we'll back out and we'll go to Swift Playgrounds. Now you can see I'm where I left off. We solved this conditional climb. It's a loop that we ran 16 times and we have a conditional inside. We have an else statement. Tell you what, let's go back to the very first and try this one over again. So we're going to go up here to the 3 dots, and we are going to reset the page. And it's going to ask, hey, you're going to lose all the code on this page. No big deal. So now if you remember, we want to use an if statement because sometimes these switches are going to be open, sometimes they're going to be closed. So far in all the other puzzles that we've done, the switches have always been off or on, and they never change once you run the code. So if I have a look here when my map loads, okay, so in this particular case, right, we ran it the first time, and we tried to write the code where byte moves forward, toggles a switch, toggles this switch after moving forward, and then moves forward and does nothing because that one's already on. And we had a bug because when we hit run my code, we'll see they actually regenerate the states of the switches. So now I would have toggled this one off. I would have toggled that one on. That would have been okay. And then this would have been on still. So I wouldn't have solved the puzzle if I didn't use conditions. So now we basically just want to test. Every time we step, we want to test. So let's try that now. Let's get byte first, move forward. Move forward. Now we're on the first switch. This is where we would use our if statement. So our if statement is down here in the autocomplete bar. So we'll hit if, and we have a condition that we can test for, and it's in the autocomplete bar here. If is on closed switch, if is on open switch. Well, we want to test to see if we're on a closed switch because that's when we want to turn it on. We don't care about this other condition. So we can say, okay, is on closed switch. Now I'm going to go tap down onto the code. And I am going to scroll over here in the autocomplete bar over to toggle switch. Excellent. And then that's it. So what I'm going to do now is tap behind here, behind these 2 dots. And I'm down on the next line. Now if you wind up, this is where, because we're using a text-based programming language and not block-based, you can miss a lot. You know, your cursor will wind up in the wrong space. It'll be on the wrong side of this curly brace. Because if I write something on this side of the curly brace, what do you think is going to happen? So if I do move forward in there, this code is only going to get run if I'm on a closed switch. Well, that might be. I might want to use something like this in the future where I have toggle switch and move forward tied together and get run at the same time. But in this case, I don't want to do that. I want to take this out of here because I want to move forward regardless. If it's a closed switch or open switch, I want to move forward. So let's tap down below again. And we'll hit move forward. And now we're on another switch. So we'll test again. So we'll get out another if block. And we'll test again if we're on a closed switch. Then we'll do the same thing. We'll toggle the switch. And then one last time, we got to tap down here and hit the if autocomplete. If is on closed switch. We're going to toggle the switch. And then that's it. We don't have to, we're at this stage, we're here. We don't have to move forward again. So let's try running my code. So they're all off in this case. So there we go. Bytes off to the races. Toggles the switch because he checks. Checks again and toggles the switch. Ooh, and you know what? What did we not do? We have a bug here. So let's try to figure out where we went wrong. Why did byte stop? Well, we could walk through this and we could say, well, okay, we have move forward. That puts them on the switch. Then we checked for the switch. Then we move forward again. And then we checked if we were on a switch and we toggled it. And then what did we do? Actually, we checked again. That's not great, because if it's closed, it would have been switched. So what we would need to do is tap here after this curly brace, and then go down here and hit this return key in my shortcut bar. And we'd want to move forward. Now, another way to debug this, because that we just walked through it and saw what byte was doing in our head. Another way to debug it, of course, is to go here to the speedometer, tap on the speedometer, and say step through my code, and then we can actually see over here where we are in the code. So let's watch that caret come through. So we're resetting. The puzzle has to randomize those switches again. Okay, so they're all closed again. So we move forward. Move forward is on closed switch. We're toggling it. We jump down here to move forward. Toggle the switch. We checked. Oh, and then we can see that there are no more dots after this one. So that means that we checked this if is on closed switch, and we did nothing because we didn't need to run this code because we were on an open switch. So we can see that, oh, actually this is where we stalled. So if we had to move forward there and we step through our code again, okay. So move forward twice. What we checked and we said, nope, we're on an open switch. And in this case, we're on a closed one. Nice. So this will be very handy when we start to get to puzzles that are a little bit less predictable. These are, now that things are randomized a little bit, it's a little bit more like real life. Like if we're dealing out cards, or if we're rolling dice and we're checking to see if the number is 9 when we roll the dice, or the number is 4, we can react to that. It makes for much more interesting games than just hard-coded stuff that we've been doing so far. Okay, so let's go on to the next page. And now this is where we get a lot more advanced here. So far, we've just done checking if something is true. And in fact, let's take a quick pause from Learn to Code 1 and go back to the answers playground for 1 second so we can really feel how the if statement's being used here. So if we go back, I'm going to pick answers copy 5 here. And basically our goal here is, so I've passed this, I have an answers playground that I can hand over to my buddy to answer some questions for me. But we also have a handy way to print things out over here in the live view. So we could do something like this. What I'm going to do is I'm going to go down here. So I just tapped on the text item in the menu bar there. I'm going to go here and add a page. That's called Untitled Page. I could give it any title I want. I'm going to tap on my new Untitled Page. And now I'm going to start typing. So there's no code written here for me. So what I'm going to do is I'm going to go down and bring up the keyboard so I can start typing in show. And I'm going to show a string. Now I want to print something out that maybe greets somebody. So I'm going to go and grab this thing. Is called this will be our string variable. So if I tap on this, it'll give me the double quotes. And then because that's highlighted in blue, if I start typing, whatever I type will replace the ABC. So let's see. I'll just say hello, comma, world. Okay, not bad. So if I run my code, I get hello world. Okay, excellent. That's good. So now let's try adding an if statement where we just check a condition. Now, what could be our condition? Let's just, to start out here, let's have it be true. So if true, and then we're going to run our code here. So what we're going to do is have the same thing. We're going to show, and we're going tap this one down here again. I'm going to bring up my keyboard so I can type something. This will show up. So let me try running that. Okay, excellent. This will show up. That's good. I was right. Now, if we go back here and tap on true, we could change that to false down here. And what do you think is going to happen? One thing I like to do, and a lot of programmers like to do, is as they're writing their code, they try to think like the computer's going to think. So they'll try to imagine in their head, what's going to be output if I run this code? So if I run this code, now I'm guessing show hello world is going to show up. And then I can kind of read this like the computer would say, well, if false, all right, false that's not true. So I'm not going to bother doing anything else. So let's run it and see. Okay. Well, to really feel this and to see this, we'll maybe add one other show. We'll pick this show string. And this time we'll grab the quotation mark from there. We'll touch on the L and drag down. And we'll say goodbye. And then touch on the L and drag down to get the quotation marks. So now if we run it, we'll see hello world and goodbye. Very quick. If I tap on the false, actually I get a nice shortcut there. I can say true there. Now if I run my code, you can see we get our extra, this will show up. Now this will get more interesting, and I think I plan on adding a little bit to this Answers Playground, and it'll be available in the Code Hub Playgrounds feed, hopefully over the weekend. I'm going to try to add a new function here that will ask you for something that will return a Boolean, right? So remember our variables. So if I have a variable here, and I'll call it is day, and I'll set it to true. And then I'll go back over here and I'll say, okay, well, true is not, this isn't very helpful because that'll always be shown. If I just say if true, that condition will always be true. So let me change it to check on a variable. So if is day, so if I happen to change this to night, let's run my code first. So is day is true, it'll show up. If I go and change is day to false and run my code, it doesn't show up. Because what Swift will do is it'll say, when it gets to this point, it'll say if is day, it'll pop up here and check, hey, what's stored in is day? Oh, it's false. Okay. So I don't have to do this. That condition is false. So I'm going to jump down here and show goodbye. Whereas if it goes up and checks is day and is day is true, when it evaluates this condition, basically just determines whether it's true or false, it'll say, oh, yep, is day, it's true. This will show up. So maybe what I'd like to see over the weekend for homework is if you could play around with conditions inside an Answers Playground. I think that would be amazing. I'd love to see some of the quizzes you guys build for each other. I think we'll try to record one here at home and see what kind of quizzes we could come up with. Usually they involve animals. I'm not saying you have to do animals, but they usually involve animals. Another thing about this playground, I really love this playground. One thing about this playground that can be a little daunting is the autocomplete bar is a little intense. So you can see I have my cursor at the end of false, and I have all these crazy things below here. CF allocator, NSURL, CF URL. That's because it's hitting the entire Swift library and a ton of different frameworks that Apple ship and real developers use to build their applications for the phone, for the iPad, for Apple TV, for the watch. All of that stuff is available to you. So you can see that, sorry, as I skipped out, you can see that this is a real powerful tool. Like, we've been using it to get introduced to coding, but you could take this all the way to your professional career. In fact, there was a really nice interview with Grace Kendall and Holly Borla from the Xcode and Swift Playgrounds teams at Apple on John Sundell's podcast that I linked to on the Code Hub, where they talked about using it on the plane if they had to prototype something or think about building a new function or feature. It's a brilliant tool for that you'll use forever now that you've gotten introduced to it. So that's your homework for this weekend. Work through the answers playground, build a quiz. If you can use conditionals, that would be amazing. But really, where you're going to practice your conditionals over the weekend is if we go back to Learn to Code 1. Try to work through these ones that we worked through yesterday. And we're going to walk through this next one, the else if one. And then that'll probably be it for today. So let's go to using else if. We're already there. Now I have a bunch of code written here already. Let's get rid of that to start over because we want a bit of practice. So the if statement is kind of interesting because it can kind of grow a bit. Because really all we're doing with the if statement is checking on conditions. Just like we mentioned yesterday with the weather, there are a lot of conditions you could check. You can check to see if it's sunny out. Okay, if it's not sunny out, can I check to see if it's snowing? Can I check to see if it's cold, if it's raining? So that's basically what we're going to do here. We have the potential to have multiple conditions here. We could be on a gem, or we could be on a switch, or we could be on nothing. So that's 3 things that we need to test for. So in our code, we're going to write something that looks like this. If we're on a closed switch, then we'll toggle the switch. Now there's your braces that contain your code. Now that one closes off that code. So if we're on a closed switch, we'll only run toggle switch. And then Swift will say, okay, cool. Well, if I'm not on a closed switch, if I'm on an open switch, or if there's nothing there, I'll go check the next thing. This says, okay, otherwise, if you're on a gem, run this code. Because those are the 2 cases where we actually want to do something. Now, if we did something like jump up for a blank one, we'd maybe say, else if is on blank tile, jump up, and we'd have our code inside braces like this. So let's do that. So it says here, we're going to move to the first randomized tile, then add an if statement. So let's start with our move command, move forward. So we're going to add an if statement. I'm going to go drag it or just tap it from the autocomplete bar. And then let's add our condition that we're checking. Let's check for if we're on a closed switch first. And if we're on a closed switch, we're going to tap on code, and we're going to toggle the switch. Okay, that's good. We're looking good so far. Now I'm going to tap at the bottom here, and I'm going to bring up my keyboard and start typing else, and then give it a space, if, and then another space, and now I get some of my conditionals that I can switch on. So I'm going to say, if I'm on a gem, I'm going to give it a space. And then we're going to use our braces, right? So you can see our braces here over the F key. So if I tap on it and drag down to the right, like this, it'll give me my pair of braces. And then because my cursor is inside the braces, I'm going to hit return. And now because I know that I'm on a gem, if I'm running this code, I'm going to call collect gem. So let's run that code. So we have enter the code to toggle the switch open if on a closed switch, and to collect a gem if on a gem. All right, so we've done that. And then we need to repeat it for the second tile. Well, let's just run it just to test our code so that we don't go rewrite this code if there's a bug in it. So let's run my code. We're going to see this stuff get randomized. Okay, we check to see if we're on a closed switch, and we toggled it. Okay, perfect. Now, so that worked fine for a closed switch. We're going to guess, if we read through our code, that should work as well for if we're on a gem. So let's go down to the next line. Let's try rewriting that again. So we're going to hit the if autocomplete. We're going to say if it's on a closed switch, we're going to toggle a switch. And then we're going to do our trick from yesterday where we tap on the braces. And we wait for a second, and then we have these items come up in our menu. So we can add an else statement, or we could add an else if statement to get that extra check. So let's tap on this button. And the condition we're going to check for is on gem. We'll go tap on our code again. And we'll collect gem. Now, if I run my code, do we think this is going to work? Let's check it out. Okay, we have 2 gems, so we've collected a gem because we checked to see if we were on a closed switch, and we didn't toggle the switch because we weren't on a closed switch. We collected our gem. Ooh. Did all my code get run? Let's see if there's maybe there's a bug. Let's check to see if all that code got run. We'll see if the dots show up after all the code that gets run. Okay. Okay. All right. So we have this code got run. So move forward. If it's on a closed switch, it was. So we toggled the switch. Then we jumped down to here because this one was true. We're then done. So we jumped to the very end. Then we checked to see if we were on a closed switch. Then we checked to see if we're on a gem. And we weren't, so we dropped to the end. You know what? We did the same mistake that we did in the first playground of the day. We didn't move forward. And sometimes that'll happen. You'll think of the code that you have to write to solve a particular problem, and you'll be thinking a couple steps ahead, and you'll forget the more mundane tasks, like just moving byte along. So let's remember to move byte along. We'll step through our code and watch what code gets run. Excellent. Okay, we did it. We managed to write an if statement with an else if clause. That's how you talk about that particular thing. You could also call it an else if branch. As we saw in the choose your own adventure diagram, it kind of looked like a tree held upside down, right? We started out at one point, and then we had 2 different branches that went off. And then from each of those branches, we had another branch off, potentially. That's a little bit like what we're doing with our if and else if statements here. So we're going to stop there for today. That's conditionals. There's a lot in here. We're going to try to maybe do a little recap of a few different of the concepts here for next week to start it off. Over the weekend, if you could work through looping conditional code, defining smarter functions, and then even boxed in decision tree, that would be amazing. I'd love to hear how it's going. Feel free to drop me a line. And yeah, hopefully this made conditionals a little bit more approachable. It's the second day as well, so you're going through it again. The most important thing you can do is stick with it. Don't get too down on yourselves. This stuff is really hard. More often than not, programmers don't have any hair because they've pulled it out because they can get really frustrated trying to talk to the machine that's very literal. You have to be very specific when you're writing code, and it's all worth it when you finally get it working and you get a little message like this at the end, impressive, or your code works and it does something that solves a problem that's important to you. So all I can say is stick with it, and definitely let us know if we're ever going too fast or too slow, and we'll try to add any little tips and tricks that we can in there to help you out. All right, thanks for joining us this week. We'll see you next week, and have a good weekend.